In question number 17, we have a geometric sequence where T2 is 6, T7 is 192, and we're asked to find n if Tn equals 768. So there's a number of different ways we can do this. We can actually set this up as a system of equations and solve for A and R. However, I'm going to do this slightly differently. I'm going to use this property that if we divide any true terms, it'll give us the R value to the power of the difference between the two terms. So for example here, I'm going to write this as T7 over T2. And if I divide those two numbers, I'm going to get R to the power of the difference between 7 and 2, which is 5. Okay, so that formula sometimes can look like this. We can have M and N on the bottom, and this is going to be N minus M as the exponent. So in this case here, we end up with 192 over 6, and that gives us R to the power 5. When I divide these, I get 32. Solving for R, I get the fifth root of 32 is equal to positive 2. So I've solved for my R value, and then I can just use that R value to figure out how far to get to N. Now we could start back at the beginning, so I can figure out that T1 is going to be 3 and use my formula for there. So it would look like this, and then I'm going to do it differently, but if we could do it this way, we can say that Tn equals 768 equals, and then we solve for T1, 3, R is 2 to the power n, and then we can solve for n using logs here. But I'm going to do this slightly differently. I'm going to let Tn equal 768, but instead of starting at 3, I'm just going to start at 6. We could start at, T2, which is 6, or we could start at T7, which is 192. It doesn't really matter. Okay, in fact, I'm going to use 192. I'm going to start at T7, and this is going to be 2 to the power n minus 7. So the power just represents how many times we use exponent between n and 7. So the n minus 7 just represents the number of steps from 7 to the n that we're trying to solve for. And we could have done this, we could have had started at T2, and then it would have been n minus 2. So solving this, when I divide this out, I get 4 is equal to 2 to the power n minus 7. I can equate the exponents. I could use logs as well. So I know that 2 is equal to n minus 7. That makes the n value equal to 9. So T9 is going to equal 768. And in fact, if we start at T7 and use that exponent twice, or so the base twice, times 2 times 2, 192 times 2 times 2 gives us 768. So this n minus 7, in fact, the exponent, all the exponent really means, and this should actually be n minus 1, that exponent just represents the number of terms between in this case here, between 1 and n. Here, this is the number of terms or steps between 7 and n.